Our theory predicts probabilities because we don't quite know exactly how this thing is configured. What if CERN's most advanced quantum simulation just revealed preliminary data suggesting a force that can shift matter and perhaps even consciousness into a parallel universe? In a routine run of exotic vacuum experiments, CERN's hybrid AI supercomputer flagged an anomaly so bizarre that it can potentially be interpreted as evidence of a parallel universe shifter. Today, we'll show you the raw data signature, explain why leading physicists believe it may challenge our universe's boundary, and explore what this means for reality itself. No slow build-up. By the end of this first minute, you'll know exactly why CERN's quantum simulation may have uncovered the first potential experimental proof of a multiverse interaction. In early 2025, CERN scientists launched a series of quantum field simulations designed to probe vacuum instabilities at energies approaching the Planck scale. These runs, powered by a bespoke AI trained on petabytes of LHC collision data, were meant to map out subtle fluctuations in the quantum vacuum. Instead, in one particular dataset, the AI detected a metric distortion that shouldn't exist under our standard model. The simulation recorded a sudden, localized shift in boundary conditions. Virtual particles vanished and reappeared with altered quantum numbers, as if a piece of the simulation had been swapped out from another domain. This swap event lasted only 12 milliseconds. Yet the statistical confidence was reported as over 7 sigma. Physicist Dr. Elena Moretti, who led the simulation team, describes it as a ripple in the fabric of our computed universe that doesn't compute. The AI agent, nicknamed Quanta, isolated the anomaly by comparing trillions of simulated events, highlighting a sequence of qubit states that aligned closely with patterns expected only if information from a different quantum sector had bled in. Could this be a simulation glitch? The team ran hardware diagnostics. No cosmic ray upsets, no memory corruption, no software bugs. Every control check passed. What remained was an event that looked like a genuine boundary breach, a signature behaving as if it came from a neighboring universe. That's not science fiction. That's CERN's data. If this kind of cutting-edge science excites you, make sure to subscribe. We dive into discoveries like this every week. To understand the magnitude of this discovery, remember what CERN has achieved before: the Higgs boson, antimatter traps, and precision tests of the Standard Model. Now they're pushing into the uncharted territory of the quantum vacuum, the sea of virtual particles and fields that underlies all reality. The goal: uncover hints of dark energy, probe extra dimensions, and maybe even glimpse the multiverse. These new simulations combine traditional lattice quantum field methods with AI-driven pattern recognition. By teaching Quanta to spot anomalies invisible to human analysts, CERN hopes to reveal physics beyond the Standard Model. And in that first anomalous run, Quanta didn't just see a blip, it saw a potential leak, the kind of leak you'd expect if two universes briefly touched. Leading theorists now call the anomaly a quantum topological shifter, a transient event where the simulation's topology realigns with that of a neighboring quantum domain. Imagine two soap bubbles pressing against each other. At a single point, Their surfaces merge before snapping back. In CERN's simulation, the quantum fields behave similarly, briefly aligning phase boundaries between universes. This isn't teleportation or classical wormholes. It's a phase alignment at the quantum level, where field configurations from Universe B overwrite those of Universe A within the simulation. During the 12-millisecond event, virtual particles in the simulated vacuum adopted properties, mass, charge, spin, that didn't belong in our standard model. Once the alignment ended, the field snapped back, but the simulation had recorded the data. Professor Marcelo Huerta, an expert in topological quantum field theory, argues that this event could be the first potential experimental hint of a multiverse interaction. She emphasizes that the anomaly's energy spectrum and spatial profile match theoretical predictions for a boundary resonance between adjacent universes in a higher dimensional brane scenario. Could we have just seen the first footprint of a parallel universe shifter? Here's where it gets even stranger. The anomaly was flagged not by human analysts, but by Quanta, CERN's quantum-trained AI. Quanta identified non-random repetitions in the metric distortion, patterns so consistent that they suggest an algorithmic structure behind the shift. In other words, the anomaly behaved like a signal, not noise. Was this a simulation glitch masquerading as intelligence? Or did we witness the imprint of another universe's physics bleeding into our data? Quanta's log files show that it compared the event to trillions of baseline runs, then elevated it from anomaly to pattern based on recurrence metrics. That level of consistency implies a persistent source, possibly the neighboring universe's fundamental laws. If an intelligence, or at least a coherent physical system, in Universe B is influencing our simulations, what does that say about the permeability of quantum boundaries? And more provocatively, could consciousness itself shift across universes if given the right conditions? These questions aren't wild speculation. They're the logical extension of what CERN's AI uncovered. Pause and consider this. If our universe can briefly align with another, what does that mean for identity, free will, and reality itself? Are we isolated islands? Or are we part of a multiversal archipelago with tides of information washing between worlds? Moments like déjà vu, the Mandela effect, even near-death experiences. Could these be hypothetical low-energy shifter events where consciousness glitches between realities? We don't know yet, but the possibility forces us to rethink everything. If you've made it this far, you're clearly into the deep stuff. Hit like and let us know your theory in the comments. Simulation, higher dimensions, or something else? Another camp of theorists suggests we're living inside a holographic simulation. According to the holographic principle, our three-dimensional universe is encoded on a two-dimensional boundary. If that's true, CERN's quantum simulation might have detected a potential leak between encoded layers. This idea draws on black hole physics, where event horizons act as information membranes. In CERN's case, the simulation's event horizon between vacuum states might have thinned, allowing data from a parallel simulation layer to cross over. That would explain why the anomaly carried a distinct topological fingerprint. It was potentially foreign code slipping into our reality. If we are inside a multiversal simulation, and CERN's experiment nudged the boundary, it raises questions about who or what is running the show. Are we part of a cosmic lab? And did our particle physicists just stumble on a potential debug mode? CERN's shifter event isn't an isolated blip in an otherwise pristine record. In fact, the deeper you look, the more cracks begin to appear in the Standard Model's smooth surface. Over the last decade, researchers across the globe have quietly flagged a growing list of anomalies, mysterious missing energy events, inexplicable bursts in cosmic ray detectors, and even the occasional false alarm for micro black hole formation in high-energy experiments. Most of these were written off at the time, labeled statistical outliers, experimental noise, or software glitches. But what if they weren't? What if they were early signs of something much bigger, smaller, less obvious echoes of the same shifter phenomenon? If that's true, it means we've been potentially brushing up against the multiverse for years without even knowing it. The event CERN's AI flagged may have just been the first time we caught it clearly, in a context where the simulation fidelity, timing resolution, and error checking were all sharp enough to isolate it. But if the shifter effect is real, if there is a mechanism by which information or quantum states can potentially transfer between realities, then it's not a one-time accident. It's a potentially reproducible feature of a layered universe, and that changes the game completely. The next step is both cautious and monumental. CERN isn't jumping to conclusions, but they're taking the anomaly seriously. The team has already greenlit a new round of simulation runs designed to push the envelope of what their lattice QCD, quantum chromodynamics, platforms can achieve. The goal? Trigger the anomaly again. But this time, under conditions that can be tightly controlled, replicated, and compared. The first target, decoherence. Quantum decoherence is what causes a system to lose its quantum properties and behave classically. By varying decoherence factors, temperature, vacuum fluctuations, environmental noise, CERN can test whether the shifter effect emerges only near specific thresholds. In other words, is there a sweet spot where the quantum boundaries between universes become more permeable? They're also planning to adjust lattice configurations in the simulation itself by changing the granularity, dimensions, and symmetry breaking parameters of the quantum field lattice. Researchers hope to identify whether phase boundaries, the points where one stable state transitions into another, play a key role in enabling the shift. This would be a massive clue tying the anomaly to fundamental topological transitions. But perhaps the most ambitious step is this: integrating quantum gravity corrections. Until now, most particle physics simulations have treated gravity as negligible, understandable, given its weakness compared to the strong and electro-weak forces. But if the anomaly involves cross-reality interaction, then gravity might be more than a minor player. It could be the key. Theorists suspect that subtle gravitational fluctuations, especially at Planck scales, could act as a coupling agent between universes. In other words, quantum gravity might be the bridge. By baking higher-order corrections into their equations, terms from loop quantum gravity, string compactifications, or even holographic duality, CERN aims to see if the shift probability increases or decreases with specific geometric or energetic constraints. If the data reveals a correlation, It will mark the first time quantum gravity has shown measurable influence in a controlled lab experiment, a significant moment. Let's assume for a moment that the replication tests succeed. The anomaly occurs again, multiple times, under varying conditions. Now, it's no longer an anomaly. It's a pattern, a mechanism, a phenomenon. At that point, the question becomes, can we control it? If the shifter effect can be reliably reproduced, scientists will race to map its parameters, field strength, energy thresholds, timing windows, entropy limits. And once those are known, the door opens to something wild: shifter engineering. Imagine being able to tune a system's decoherence profile until it enters the potential leakage zone. Then imagine using that moment to encode quantum information, data packets, messages, perhaps even entangled qubits, and watch as that data potentially shifts into another realm. Not metaphorically, hypothetically. This would be the first form of interuniversal communication, the cosmic equivalent of sending a message in a bottle across the layers of existence. And that's just the beginning. If information can travel, what about particles? What about energy? Could we someday build machines that extract energy from vacuum fluctuations caused by reality intersections? Could we offload entropy into another universe to keep our own systems running longer? It's speculative, it's theoretical, but it's not impossible, and that alone makes it revolutionary. If shifter events are real and controllable, the implications stretch far beyond technology. The entire philosophical foundation of modern science shifts. Up to now, every law of physics, gravity, relativity, quantum uncertainty, was thought to apply universally. But if realities can intersect, then physical law becomes a local rule set, not a cosmic constant. What's real here might be optional elsewhere. In this new framework, the multiverse is not an abstract possibility. It's a potentially measurable reality space. Different rules, different histories, different outcomes, accessible, if only momentarily, through quantum edge effects. And here's the wild part. This might explain phenomena we've never been able to pin down. Dark matter? Maybe it's mass from a neighboring universe that gravitationally overlaps with ours. Quantum entanglement? Perhaps it's just local evidence of two particles sharing multiversal entanglement. Time symmetry? What if time flows differently across layers? And we're seeing the effects of interuniversal drift. Suddenly, unanswered questions become potentially solvable mysteries, and with each answer, the universe grows less like a machine and more like a multi-dimensional network, a neural mesh of realities firing, linking, evolving together. There's one last layer to this, one that goes beyond physics, beyond simulation, even beyond science. If we learn to trigger the shifter effect, if we gain the ability to speak, send, or sense across the veil, then our place in the cosmos could potentially change forever. We are no longer confined to this one realm. We are not isolated observers. We are potentially participants in a multiversal civilization, one that may stretch across infinite worlds, infinite timelines, infinite dreams. And just like that, human destiny might expand, not into stars, not into space, but into possibility itself. We used to look up and wonder if we were alone. Soon, we may look sideways and realize we never were. And it all starts with one glitch, one flicker of impossible data, one shifter. What comes next is potentially everything. We began by asking a radical question. Can a quantum simulation reveal potential proof of a parallel universe shifter, a phenomenon that doesn't just hint at other worlds, but potentially interacts with ours in real, measurable ways? Now, after walking through the layers, CERN's AI-flagged anomaly, theoretical models like topological shifts and holographic leaks, and eerie echoes of past unexplained data, we find ourselves standing at the edge of something that could potentially rewrite the very structure of reality. For centuries, physics operated under the assumption that the universe was a closed system. All that exists, exists here. The Big Bang set the rules, and everything else plays within that sandbox. But now, that assumption is starting to crack. The data from CERN doesn't merely point to a strange anomaly. It suggests potential bidirectional interaction, like two systems brushing up against one another and swapping pieces of code. Let's pause on that for a second. If the universe can swap code with another system, even momentarily, then what we're dealing with is not just a passive reality. It's an active, layered structure, one in which boundaries aren't impenetrable, but more like semi-permeable membranes. Membranes that might flex, bend, or even momentarily align under specific quantum conditions. This kind of universe, porous, dynamic, fundamentally interconnected, forces us to reconsider not just physics, but ontology itself. What does it mean to be real? If there are multiple realities brushing against one another, could events in one universe influence decisions, probabilities, or even histories in another? In classical mechanics, we dealt in absolutes. In quantum mechanics, we dealt in probabilities. But now, we might be looking at entangled realities, where the laws of physics are not universal constants, but local configurations. What applies here may not apply there, and yet, somehow, the there can still touch the here. This possibility breaks open the biggest questions in modern physics. Why are the fundamental constants what they are? Why does our universe allow for life, complexity, consciousness? Is the fine-tuning of physical laws the result of natural selection across multiverses? Or is it merely an observer effect? We exist in this universe because it's the one in which we can ask the question. If CERN's simulation is correct, and if it's replicable, then this anomaly gives us more than theoretical answers. It gives us potential empirical data about what happens when our universe is not alone. Imagine reality not as a single, unbroken plane, but as a mosaic, a complex structure made of countless interlocking pieces. Each piece is a universe. Some touch only a few others. Some overlap at multiple edges. Some pieces are larger, some smaller, some fading in and out of alignment. This is the multiversal mosaic. And for the first time, CERN may have glimpsed the seam between two tiles. These aren't fantasy metaphors. String theory, M theory, and loop quantum gravity have long speculated that higher dimensional brains, giant sheets of spacetime, could float in a higher dimensional bulk, occasionally colliding or brushing against each other. When they do, energy is transferred, fields overlap, realities resonate. CERN's shifter anomaly could be the resonance pattern of one such brush, a whisper from the universe next door, rippling into ours, captured in 12 milliseconds of digital simulation. And this is where we stretch even further, into the territory where physics meets philosophy. If universes can shift data, what else can shift? Could consciousness itself be non-local? Could it be that part of who we are, our awareness, our perception, our self, is not bound entirely to one universe, but spread thin across many? This might sound theoretical, but some physicists and neuroscientists are already exploring the idea of quantum consciousness. That the brain may operate at a level where quantum coherence plays a functional role in perception. If that's true, and if the multiverse is a physical reality, then we have to ask, is some part of you already aware of those other layers? Could déjà vu, intuition, or sudden flashes of insight be micro-interactions with a version of you that made a different choice in a parallel branch? What if memory glitches like the Mandela effect aren't just tricks of the brain, but hypothetical echoes from neighboring timelines brushing against ours? These questions aren't the stuff of science fiction anymore. They're entering the domain of theoretical metaphysics, thanks to anomalies like CERN's. CERN scientists are planning new simulations, controlled vacuum states, adjusted lattice geometries, attempts to induce the shifter phenomenon intentionally. If successful, we may be witnessing the birth of a new field, multiversal physics, the attempt to systematically probe, measure, and eventually study the connections between universes. One major goal: to determine if the anomaly can be used to transmit information across universes. That would change everything, from physics to communication, from exploration to ethics. But even before that, there's the philosophical upheaval. Science has always been about mapping the unknown. But what happens when the unknown pushes back? What happens when our map leads to a door, and the door begins to crack open? Every so often in history, science undergoes a shift so deep that it redefines the human condition. The Copernican revolution dethroned Earth. Darwinian evolution dethroned humanity. Relativity and quantum mechanics dethroned determinism. Now, CERN's data may be preparing to dethrone singularity, the belief that we live in one world, one timeline, one history, and here's the most important part. This isn't the end of the story, it's the beginning. If reality is layered, and if these layers can touch, then every law, every constant, every outcome we take for granted may just be one version among many. We're not just discovering new particles anymore. We're discovering new possible versions of reality itself. So maybe the truth is this: we've never been alone. Not really. We've just been waiting for the right lens, the right simulation, to catch a flicker of what's potentially always been there. A shiver in the vacuum, a whisper between worlds, a 12-millisecond glitch that opened the door to new possibilities. Welcome to the age of the potential parallel universe shifter. If this discovery changed how you see the universe, you won't want to miss what's next. Subscribe and turn on notifications so you don't miss it. Next time, CERN's latest experiment, the search for the quantum.